Welcome to the logic world. There will be a series of videos on logic problems. This is part 1 on cryptograms. So, what are cryptograms? They are logic puzzles where letters stand in for the digits of a number. Each letter represents a unique digit, often from 0 to 9. They are usually in capital letters. If the same letter is used twice, it's the same digit in both places. If it appears thrice or more, it's also the same digit in all places. Let's go through some of the basic rules. When one digit is added to the other, there will be no carryover or a carryover of 1. Please note that no carryover of 2 or more is possible, because the largest possible sum at any place value would be 9 plus 9 and a possible carryover of 1 from the previous place value, which would be smaller than 20. Similarly, when 3 single digits are added together, the carryover, if any, can be 1 or 2 only. If it is easier and neater, repeated additions can be represented as a multiplication, and a product of two numbers can be represented as a long division. Okay, we will go through 5 examples covering the common operations, including addition, multiplication, division. Following the examples, there are 2 practice questions. Now first, let's look at example 1. Look at the figure here. What digits in place of A and B would make this sum true? Now this is a very simple puzzle. Look at the last column. The sum of B and 6 resulting in a 1 in one's place, we must have B plus 6 equals 11. Therefore, that means B equals to 5. Then we have the value of A to be 1 plus 5 plus the carryover from the ones digit 1 being 7. So let's check the solution. 15 plus 56, which is 71. As you can see, we do not need to find the values of the letters in alphabetical order. In this case, we find the value of B first, and then the value of A. Now, example 2. In this figure, what digits in place of A and B would make this product true? For this example 2, I will present you 2 methods. First method. Based on the 6 times table, the product of 6A ending with A requires A to be even because 6 is even. That means A can be 0, 2, 4, 6, or 8. So now let me tabulate the value of 6A ending with A. And the second column over here records the carryover to the tens place. Now let's look at 6B. Okay, the carryover 6B plus a carryover from 6A result in 16, which means the carryover must be even, because 6B itself, the product is even, and the final answer is 16, also even. That explains why the carryover from 6a must be even as well, which has been highlighted in red. So either you have a carryover of 2, 4, or you don't have carryover at all. After try and error, 6b plus the carryover equals to 16, we can solve the unknown in this equation, and we are not able to find b to be integer values for these two cases, which means the only possible value of b will be 2, having a carryover of 4 from the ones place. So with this, we have already figured out the correct product. 28 multiplied by 6 equals to 48, a carryover of 4, 12 plus 4, 16. So answer A is 8, B is 2. In method 2, we look at this problem as a long division instead of product. Apparently, following the long division procedure, b equals 2. Then 6 multiplied by a number equals to 40 something. The number is either 7 or 8, because 6, 7 is 42, 6, 8 is 48. Since 6 multiplied by 8 is 48, the value of a must be 8. That is, a equals 8 and b equals 2. Comparing the two methods, which one do you prefer? In example 3, we need to fill in the blanks. Since no letters are assigned, repetitions of digits are allowed for the blanks. Based on the remainder 0, we know that the single-digit divisor is a factor of 60-something. Recalling times table, we only have the product of 7, 8 giving 63, or the product of 8 and 8 giving 64. First, let's try the divisor to be 8. After trial, put down the 8. So 8 times 8 is 64. Then I work backwards. Since this is single digit, it must be 8. 1 times 8 is 8. 6 plus 8 is 14. So we are working backwards because we are having, so now I'll bring up, this is 4. Again, this is a single digit, must be 8. So which means here is 1. 1 times 8 is 8. And the number here, it is 9. But now actually I have a 4-digit number instead of 944, which means 8 cannot be our divisor. If 8 is not able to be our divisor, then let's try 7. So this is 7. 7 times 9 is 63. 63 minus 63 is 0. Now we need to work backwards. Single digit 7. 1 times 7 is 7. 6 plus 7 is 13. So here must be 3. 13 here, single digit again, must be 7. 1 plus 7, it will be 8. But you are given a 4-digit number instead of 833. Therefore, 7 also cannot be the divisor, which brings us any other choices, but the divisor must be 9. Let's verify the answer. 7, 9 is 63. This is correct. So single digit 9, 6 plus 9 is 15. So here must be 5. Here must be 1. 1 times 9 is 9. And working backwards, Okay, single digit here again, so this is 9, this is 1. 1 plus 9 is 10, a 4-digit number. And we can go according to our long division procedure using 1053 divided by 9. Indeed, we will get a quotient of 117 with the remainder 0. Here comes example 4. It is taken from Singapore Mathematical Olympiad or SMO 2015 Junior Section Question 5. In the figure math plus math equals habit, each letter represents a unique digit such that the sum holds. The question asks what's the value of B. Option A, 0. Option B, 2. Option C, 4. Option D, 6. Option E, 8. Basically, all the even digit choices. Since math plus math, it's repeated addition, we can write into multiplication like this. Math multiplied by 2 equals habit. Note that the digit 2 is not used when it is changed to multiply by 2. And the value for h must be 1, because if we choose m to be 9, 9 multiplied by 2 is 18. Even if you have carry over, the h will be only as much as 1, which we have explained as the first basic rule. Knowing h is 1, then t must be 2. 2 times 2, I must be 4, which we will have this. Now next, let's look at the product of A and 2, ending with a B. That means B must be even, because 2 is even. 2 multiplied by A gives you an even number. Since 2 and 4 has been used, B can take the value of 0, 6, or 8. Now if A is 0, then 2A is 0. A and B both taking the value of 0, which is not allowed. Therefore, A cannot be 0. A also cannot be 6, because 6 times 2 will give you 12. Then B will be taking the value of 2, which has already taken by T. So A cannot be 6. How about 7? If A is 7, 7 times 2 is 14. Again, 4 is already taken by letter I. So therefore, A also cannot be 7. Therefore, A can only be 3, 5, 8, or 9. Now let me tabulate the value. For A can take the value of 3, 5, 8, and 9. And just now we talked about B must be even and taking the value of 0, 6, or 8. Alright, and then we want to work out what's the value of M and see whether it is possible or not. So if we take the value A to be 3, B must be 6. Then 2M becomes 13. 13 divided by 2, M equals to 6.5, which is not an integer. So this combination is not possible. Okay, now let's look at when A equals to 8. 8 times 2 is 16 with a carryover. So 18. M times 2 plus 1 equals to 18, which will result M to be a non-integer again, which is also not allowed. If it is 9, 9 times 2 is 18, so B is 8 with the carryover 1. So here is 19. 19 minus the carryover 1 is 18. 18 divided by 2 is 9, so M is also 9. But we are already assuming A is 9, so which will result in both A and M being 9. Again, this is not a possible combination. Therefore, the only possible combination is A equals to 5, B equals to 0, M equals to 7. Let's verify it. Example 5 is taken from SMO 2016 Junior Section Question 1. This is the figure. I square equals to me, I cube equals to you, and all the letters representing different digits. The question asks, what's the value of E? Alright, okay, this question, when we look at the square and cube, a number squared equals to a double digit, which means your I will be at least 4. So 4, 5, 6, 7, 8, and 9. If I cube equals to a 3-digit number, your I must be at least 5, because 5 cube is 125, 4 cube is 64. Therefore, I must be 5, 6, 7, 8, or 9. Furthermore, if we look at ending digit 5, if we square it, become 25, so ending with 5 again. But I and E must be different letters, so I cannot be 5. For the same reason, I cannot be 6 as well, because 6 squared is 36. So which means, okay, our choices for I will be 7, 8, or 9. Now let's construct a table of values for I squared and I cubed. So 7, 8, and 9. Let's verify the values one by one. When I is 7, I square is 49, so me is 49. I cube is 343, which is U. Since we have 3 for the hundreds and ones place, but Y and U representing different letters. Therefore, this is not correct. How about when I equals to 8? I square is 64, I cube is 512. We did not violate any of the conditions, so this is possible values, which means I can be 8. How about I being 9? Let's verify it. If I is 9, I square is 81, I cube is 729. Again, I is 9, U is 9, repeated. So this is not correct value for I. In the end, the only possible value for I is 8. Okay, therefore, the value of E will be 4. Now that we have covered 5 examples, it's time for you to do some practices. Practice 1. It is taken from SMO 2014 Junior Section Question 7. Terrible number equals to 13. Again, each letter represents a unique digit such that the sum holds. The question is, if L is equals to 9, what's the value of T? Even though this is an ill fortune question, I'm sure you'll be fortunate enough to work out the value of T. If you wish to try it on your own, please pause the video now. Here are the hints to practice 1. You may follow the suggested sequence. And here are the detailed hints. Hope you can figure this out. Here are the answers to practice 1. Did you get them correct? Practice 2 is taken from SMO 2016 Junior Section Question 15. 40 plus 10 plus 10 equals to 60. As usual, Each letter represents a unique digit such that the sum holds. The question asks, what is the 5-digit number represented by 60? If you wish to try it on your own, please pause the video now. Here are some hints to practice 2. You may follow the suggested sequence, and here are the detailed hints. Hope you can work out the cryptogram. Here are the answers to practice 2. Did you get the cryptogram correct? Here are the examples we went through involving addition, multiplication, division, square, and cube. To solve cryptogram, we always start with the most critical relationship, which we know for sure the digit the letter represents. When this is not possible, we narrow down to a few choices, and a trial and error method using a table proves to be helpful. Hope you have learned something. Thank you for watching, and happy cracking cryptograms. Stay tuned for more logic problems.